Hello and welcome to the fourth part of our TFS walkthrough, and this time we are going to close the topic of testing in Visual Studio 2010 and Team Foundation Server 2010, and we are going to talk about mainly three things today. And the first thing will be the test impact analysis. The second thing will be the coded user interface test, and then we will speak about the load testing of your web applications. So we begin with a test impact, and unlike the previous demonstrations, unlike the previous walkthroughs, this one is more relying on the blog post. So you will see URL now on the screen, and for more theory regarding these tests, regarding this subject, please refer to that blog post, as I will simply have no time to explain it all in the video. And if this topic is relatively new for you, then it will be easier for you to read about it than to hear me explaining it. I will try to explain most of the things that you will see, but some things perhaps will require some reading. So let's proceed with the impact analysis. And what it is basically unit tests. As you remember, in the previous part we were discussing the unit tests, and impact analysis is well, its basic meaning is that when you are changing your code, when you perform changes, some unit tests are impacted, which means that your code change is relevant to this unit test, or let's better say, this unit tests are relevant to these parts of code which you are changing. So if you have a unit test for a procedure and you are changing this procedure, then the only impacted unit test will be that particular unit test for that particular procedure. And Visual Studio gives you the possibility to run only the impacted tests, and we are going to see now how it's realized in Visual Studio. So we open the solution that you remember from the previous demonstration. It's a simple math application, and we are going to edit test settings and local test settings, just like in previous demonstration. And in the test settings dialog, we are going to data and diagnosis, and choosing the test impact. And here you may notice the configure button, but we don't need it at the moment. So we already have the unit test project. We just switched on the impact analysis, rebuilt our solution, and now when we are going to test view, we see all the tests which exist in the unit test project. So we run them all. It was necessary to do just so we wouldn't have any impacted tests. Yeah, so no code is changed since last test, so no impact at the moment. But now we are going to a function, and instead of simple return, we are doing absolutely the same thing, but now we are introducing the variable and returning this variable. So this function is doing absolutely the same, it will work absolutely the same, but it's a different code. So while we are pretty much sure that it will work, still we will have to test it. And the principle of the impact analysis is that for now only these two procedures are affected. They were changed, so their unit tests are affected, and now it's the third function. We are doing absolutely the same. We are introducing the variable and returning it. Now we should save it all and rebuild the solution. And now if you are going to test impact view, it's another menu, not just a test view but test impact view. You see 3 unit tests which were impacted. You can see a little warning here that 3 tests are impacted. So you can either click that link, run tests, or right click and run all impacted tests. Doesn't matter what you will choose. I will just click the link, and the 3 impacted tests will be run. Of course they passed because well, the code is working just as before. So because of that functionality, when you are having like say 100 unit tests, or hundreds, or maybe even 1,000, it depends from your project. When you are making changes and when you are making local builds, or perhaps you are making builds on your TFS, you can make a setting. You can set that only impacted tests will be running, and that will ensure that your build will be done much faster. Because sometimes, especially on on big projects, running unit tests could take half of an hour or maybe even more. It depends from your hardware and the amount of tests and the complexity of this test. And now we are going to since I've been talking about the complex tests, we are going to review such thing as the coded user interface test. So we are creating new test and selecting the coded UI test. UI stands for user interface, and you will see what it is if you don't know it yet. We are selecting the test project, the project which contains the unit tests. And we've chosen to record actions, and that's a brilliant feature of Visual Studio. As you can see, the recorder window appears and the Visual Studio is minimized, and we are starting recording our action, and now we can do whatever we want. We are running the application, the calculator application. And what we just did, we recorded this as the step because we could repeat this step in many tests, because it's very generic. We are just running the application. Then we continue recording and doing some input into the first text field, input into the second test field. Click the button to add two numbers and record this step. And call it add 10 and 10. And now what we are doing, we are pointing at the result text box. We just dragged the target. And now here we should assert that the value in the text box is 20. The control specific property, control specific means that of the type text box there is a specific property text, and we add assertion to assert that the value of that text property equals, but as you can see there are many possibilities, like ends with and so on, but in this case it's equal to 20. So we must ensure that if we enter 10 and 10 and then click plus, then the result will be 20. And we call this step the assert add. So we assert that add is okay. This is nearly all, but we also need to close this application and record it as the last step. We call it close calculator. We add the step, generate the code, and then simply close the recorder. And what we see here in AddUI test now are all the steps that we made. And as you may notice, the step like open calculator is recorded as a function, so we can use it in other test methods, because I think nearly all test methods will start with opening the application, and then we can use other functions like add 10 and 10 and then assert that add and so on. We can use them in other tests as well, the same as we could use the close calculator as the last step of every other test method. That's quite obvious. So we can just test this method, but instead, first thing we will do, we will rename it. Through refactoring, always rename your functions through refactoring, because it will also change the references to it. So we call it AddUI test method, because it's about the adding function of the calculator. Then we will build this solution. And now, as you can see in the list of tests, we have a test with another icon, which is a user interface test. and we can simply run it as any other unit test. And in the background it does all the steps that we did before. Runs the application, inputs values, and asserts that result is expected. And then of course the result is passed. And what we are doing now, we are creating another project which will be a load test for a web application. So for example, and this is perhaps the next degree of complexity, sometimes you are building websites and you need to test them, like for example, what will happen if 20 or 50 users will connect and use some functionality of my website, and perhaps some of them will use Internet Explorer and some will use Firefox or other browser, and they will do quite different things, but simultaneously at the same time. What will happen? What will happen to my server? What will happen to its memory, to its processor, to its hard drive, to whatever? So you need to assess it. So you will be able to tell that your application is capable of running simultaneously with 100 users or with 1,000 users and so on. It will not be just a number from your head, it will be a number from your tests, which is different. And of course, if it's a distributed application, like your application web project is designed to work in web farm, then you must have the possibility to run this website on a farm and test it from more than one location. So it's not like your website is running on your developer machine and all the clients are connecting to your server from your client's machine. So distributed applications require distributed tests. And fortunately for you, the TFS will be able to run such complex tests on every build or nightly build or wherever you want. So everything you need to do is to create such test once. And we are going to create such test now. So we are creating the Visual C# test project. We call it web tests. And we are creating a new test, which is web performance test. It's not basic unit test, it's not coded UI, and notice the description which says that you can use a web performance test with a load test to test the performance of a website. So obviously we are going to test the performance of our website. And it's very important even when you're just changing your code, because some changes like to your database interface, when you're going to start using stored procedures or entity framework instead of ADO.NET, so you want to know how much time, for example, you are wasting on a particular task like accessing the database, how much time you are spending in your data layer, what is the bottleneck of your project. The only way to find it out is to use web performance test. So it's not just I don't know, rare beast that will not be used in your project. You should use it, especially if you are thinking about any future for your project. If it's not like I don't know, school project. If it's something real, then web performance test is a must. So we're creating the web performance test, and we'll call it the query test. We add it to the test project of web tests. And just like Recorder previously, now we have running Internet Explorer, and we are accessing the website which was in our favorites bar, and it's our TFS server, by the way. So we are going to assess our TFS server performance. We're going to run some queries. In real life you wouldn't use the TFS website in this case, but your own website, of course. So we recorded everything we needed. And stop recording. There were no dynamic parameters like session ID or whatever, and Visual Studio is smart enough to detect them. And now, just like previously, we can run this test again. Oops, I ran more than one test at once. I ran it twice, but the first one succeeded, the test passed. And now we are adding the load test, and as you can see in the description, you are using a load test to aggregate tests and run them simultaneously under simulated load using virtual users. For example, load tests let you test the performance of a web application under peak use before you deploy it. So what does it mean? It means that we will create virtual users, virtual user profiles, so they will be able to access your website like real users. So you can create 100 users which will each have their own session and acting like they are using specific web browser, and they can do absolutely random things, well, randomly selected from previously recorded tests, and they will not do it like denial of service attack. They will have they will behave more like real human, meaning that they will have think time, and think time means that between actions they will have some delays, some latency, like if they are thinking what they are doing, for example. So we are creating the load test. As always, we are giving it a better name, like query load test. Fortunately, we have a wizard for it. Give it a different name, like query my tasks. As you remember, in TFS we were querying the my tasks query. The think time between iterations is what you will need to do when performing real tests. So setting like 3 or 5 seconds, it depends from your users actually, because if your users are using your website quite often, if it became the platform for their business, then most likely the think time will be very short. But if this is a website like, I don't know, photo gallery for absolutely generic customers, like I don't know, teenagers who upload and share their photos, then most likely the think time will be bigger, because well, you know, you have to put some analytics into it, because you have to simulate in your mind how they will think and how they will work with your project. So when a teenager is uploading the photo, what he is doing, he is, for example, reviewing that photo. Does he want to upload really this photo, and maybe he needs some changes to do? Most likely it won't be a very fast decision and very fast action. Also, you will have to think about what is the usual speed of the internet connection for your users. And a perfect place for getting that information is Google Analytics. It gives you also information about what providers your customers are using, what are the usual speeds of connections. So you should really take the analytics of your website, if it already exists, and put it into this test. So in that case, your test will be very, very close to life, as much as it can be. And think time profile, as you can see, there are 3 options. Use recorded think times, use normal distribution centered on recorded think times, or do not use think times. I always suggest you are using think times and use the normal distribution, just like in this example. So we click next. And the load pattern is another good feature. Like, you can set the constant load, which means that you will always have 25 users who will work with your website, or you may have a variable count of users, which means that they will start from 10, and each 10 seconds 10 new users will come. So this will be a sort of slash dot effect, like you have a news which refers your website, and not everyone is immediately reading that news, but usually within 1 hour thousands of people could read that news and reach your website. And since your website usually has some information like article or whatever, people will spend some time on your website, and using the Ajax and similar technologies, they will stay on your website, so they will count as a current user. So in this particular case, you will need the step load feature of the load test, and can start from one count, like 10 users, and with various steps. like every 10 seconds add 10 new users. In our case, we will start from 2 users, and every 1 second we will add 2 users. So in the end there will be 20 users. The reason for that is that because we are running it on one machine, and the test mix model will return to it a bit later, meaning that users will either do the same action, every one of them, or they will do mix of actions, like you have a few steps and they can be interchanged, and so they will be changed randomly. So for example, if it's a normal website, then people log in and then they can do different things like upload photos, or look at photos, or rank them, do whatever, send messages like private messages, and post to forum, whatever they can do in your website. So these multiple steps can be mixed and mixed randomly. So in that case you will have a simulation of how your website will work in the wild. And here we are adding tests to the mix. The problem is we have only one test, which is query test, and the distribution will be 100%. If we would have more than one test, we would be able to change distribution, like 20% of users would do that query test, and 20% something else, and another 60% would do something else. In real life you will use something more than one test. The network type and browser type. The network type is LAN, which means high-speed connection, 100 megabit or perhaps gigabit connection, which means we have no problems with speed. But we could choose also the modem connection, so that means 56 kilobits or maybe 128 kilobits per second maximum, which means that perhaps some pages would load very long time or not load at all. And the browser type, by default is Internet Explorer, but we have here Chrome, Firefox, some ancient Internet Explorers and Netscapes, and so on and so on. And you can extend that browser types. So for example, if your website has some different markup features for different browsers, you can test them here, including the mobile browsers. And so half of our users will use Firefox 3, and half will use Internet Explorer 7. Not the most modern browsers, but it can be changed. In this particular example, we just don't change it. Now, just as I said that distributed solutions require distributed tests, here is where we can select computers and counter sets. So different computers would run these tests, and we could monitor their load. But in this particular case we have just one computer, and we don't have agents installed on other computers. So we just click next. And the load test duration, how much time we have for warm-up and for running. Warm-up means so we should wait until the server will load and so on. The running duration is the duration of the test, which is 10 minutes in this case, and how much iterations for the test will provide. Test iterations is a function instead of load test duration, which means that no matter how much time it will take, we will run 100 iterations, for example. So for the sake of simplicity, we will run it for 2 minutes. I just don't want you to wait 10 minutes for test to pass. So now the test is in the progress, and we see the error because the test is not connected to the database. It doesn't store the results in database, so we will not be able to export this test, but it's okay. It's okay for us in this particular case. But still we see the how test is running and how much resources it takes, and how much time each page is using to load. There is every possible counter that you may need for your test, and when you will have the test, when you will play with query load, ensure that you read all these counters and you understand what they mean. As you can see, there are many counters, and you can either display or just record their values. Yeah, we don't have connection string for the database, of course, so we will not be able to save this test, but it was done just for simplicity. To not install the SQL Server for this test. In real life, you can use the SQL Server like Express Edition, which is free. Setting storage type to none will not fix the error. We will still see the error, so don't do this. You'd better really set the database, unless you don't need to save the information. Okay, so we are not saving anything, but the most important thing is that we see that how much resources our test is taking, how much resources our system is taking when put into sort of real-life conditions. we have 0 errors per second, and well, at least this is perfect. And taking into account that we are testing it on one machine, it doesn't really matter how much is the response time. But well, when you will run it on your machine, the most important thing will be to use to record this into a database, so you will be able to export and run this test later. Well, I think that we've finished on this one, and I think that we will return to tests in one of the later demonstrations. The next demonstration will be about the architecture. As you can see, the architecture menu here on the above is the only feature of the Ultimate edition of Visual Studio. But still, if you are interested, if you are planning to become the architect or at least senior developer, then it will be interesting to you. I don't know when I will release it. Perhaps anytime soon, maybe in a week, maybe a bit more. But you can visit now the blog, and well, you can subscribe to new releases, new articles, and then you will be notified when it will be released. Well, thank you for your attention and for watching this. If you have any comments, feel free to comment either on YouTube or in my blog.